Human societies began long before the first controlled experiment, yet even in their earliest stages they sought explanations for the surrounding world. Myths arose as structured narratives, not random tales, designed to impose coherence on a landscape of uncertainty. They functioned as an intellectual framework through which phenomena such as seasonal change, illness, or celestial motion could be interpreted. Where later centuries would demand reproducible observation and quantitative measurement, early cultures relied on symbolic stories that preserved practical knowledge and conferred authority on those able to transmit them. Anthropological research demonstrates that oral traditions were not merely entertainment but encoded rules of survival. Among the Aboriginal peoples of Australia, for example, songlines map geography, water sources, and seasonal shifts with an accuracy that has been verified by modern cartographic surveys. These narratives appear mythological on the surface, depicting ancestral beings whose journeys carved rivers and mountains, but they served as reliable guides across thousands of kilometers of desert. The same functional element appears in Inuit stories of animal spirits. The tale of Sedna, mistress of the sea, instructs hunters to observe taboos that maintain balance in seal populations. In both cases, symbolic explanation anchored ecological practice. The connection between myth and proto-science is also visible in agricultural societies of Mesopotamia. The epic tales of gods Enlil and Enki are intertwined with observations of flooding in the Tigris-Euphrates basin. Recorded on clay tablets from the 2nd millennium BCE, they emphasize the necessity of rituals timed to the swelling of rivers, indirectly encoding what we would now describe as a rudimentary hydrological calendar. Archaeological stratigraphy at Uruk and Ur shows clear evidence that such myths coincided with the earliest irrigation systems, which required prediction of seasonal water flow. Myths therefore stabilized technical knowledge by embedding it in collective memory. Philosopher Ernst Cassirer argued in his Philosophy of Symbolic Forms, 1923–1929, that myth represented a legitimate mode of understanding, distinct from but not inferior to science. Cassirer observed that myths sought causality in the same manner as scientific theories. Both aim to reduce uncertainty by positing consistent relations between events. When the Greeks told of Zeus hurling lightning to punish hubris, they proposed a repeatable correlation between thunderbolts and human behavior, even if the causal mechanism was theological rather than physical. The need to impose order on chaos is the common thread. The boundary between myth and science is further blurred when examining early explanations of disease. In Mesopotamian incantations preserved on Assyrian tablets, illness was often attributed to the intrusion of malevolent spirits, yet the prescribed rituals, fumigations, herbal mixtures, controlled diets, correspond to interventions with measurable physiological effects. Later medical texts such as the Edwin Smith Papyrus from Egypt, circa 1600 BCE, show a transition from mythological framing to observational description, yet even their incantations remain alongside surgical procedures. The mythic narrative maintained authority, while practical experimentation gradually gained ground. It is therefore inaccurate to dismiss myth as irrational. Instead, it functioned as an early cognitive technology, allowing humans to store, transmit, and justify bodies of empirical knowledge without the apparatus of experiment or mathematics. The transition to explicit science required new conditions: written notation, long-term data storage, and institutions dedicated to inquiry. Before these developments, myth was the only available tool to integrate scattered observations into coherent systems. Comparative linguistics reveals that many of the oldest Indo-European myths share root structures that describe order arising from primordial disorder. The Rigvedic hymns of India, composed between 1500 and 1200 BCE, speak of Ta, the cosmic order sustaining natural cycles. In Greek Hesiodic tradition, chaos precedes the formation of Gaia and Uranus, establishing a lineage of explanation from disorder to structure. Babylonian cosmology in the Enuma Elish likewise begins with watery chaos personified as Tiamat. The recurrence of this pattern across civilizations indicates not arbitrary invention, but a shared psychological imperative, to articulate why structured reality exists rather than undifferentiated flux. This drive to connect present experience with a deeper explanatory order persisted across millennia. When later philosophers in Ionia began recording speculative theories, Anaximander proposing the apeiron as the boundless source of all things, or Heraclitus emphasizing flux as the principle of reality, they were reframing mythological motifs into nascent natural philosophy. The continuity is evident. Myth had already provided the cognitive scaffolding. What separates myth from systematic science is not the presence of explanation, but the method of verification. Myths gained credibility through ritual repetition, communal affirmation, and alignment with observable cycles such as planting seasons or migrations. Science, by contrast, would demand falsifiability and predictive power independent of tradition. Yet in both cases, the underlying motive was identical: the search for patterns in phenomena that otherwise appeared arbitrary. From this vantage, myths must be regarded as humanity's first attempt at natural science, though expressed through symbolic figures rather than empirical models. They reveal the earliest strategies by which human beings confronted the unknown, translating experience into ordered narrative. The endurance of such stories across continents suggests that they met a universal psychological need. What remained unresolved was how these narratives could adapt once observation began to contradict their assumptions, a tension that emerged most sharply in attempts to describe the origins of the world itself. The human demand to explain origins expressed itself with particular intensity in creation myths. Across civilizations separated by oceans and centuries, narratives developed in which the cosmos arose from a primal void, a cosmic struggle, or the sacrifice of a primordial being. These myths cannot be reduced to mere allegory. They represent coherent attempts to account for the fact of existence and the ordered structure of the observable world. Their persistence across cultures underscores the psychological urgency of origin questions and the intellectual continuity that runs from mythic cosmogonies to modern cosmological theories. In Mesopotamia, the Enuma Elish, inscribed on 7 clay tablets dating to the late 2nd millennium BCE, describes a universe born from the mingling of fresh and salt waters, embodied in the deities Apsu and Tiamat. Conflict between these primordial forces results in Tiamat's dismemberment, her body forming the vault of the sky and the foundations of the earth. This act of cosmic violence functions as an explanatory mechanism. The material world becomes intelligible as the reorganization of a pre-existing, chaotic substance. Archaeological evidence suggests that the recitation of the Enuma Elish during the Babylonian New Year festival reinforced not only cosmological order but also political hierarchy, for the elevation of Marduk as the victor mirrored the supremacy of Babylon among Mesopotamian states. Here, cosmology and governance converged, binding natural and social order into a single explanatory scheme. Greek cosmogony preserved in Hesiod's Theogony, c. 700 BCE, likewise begins with chaos, an undefined expanse, from which Gaia, earth, Tartarus, the abyss, and Eros, desire, emerge. The subsequent generations of deities represent attempts to structure the elements of the natural world, sky, sea, night, and light, into a genealogical system. The very act of placing natural forces within a lineage reveals a proto-scientific instinct. Phenomena must be related, not isolated. Heraclitus of Ephesus, writing 2 centuries later, would transform this genealogical framework into a principle of physical flux, but the foundation remained the same. Order emerges through relational structures. South Asian cosmology, articulated in the Rigveda, presents another dimension. Hymn 10.129, often called the Nasadiya Sukta, contemplates the origin of the universe not through divine combat, but through the emergence of existence, Sat, from non-existence, Asat. The hymn's closing lines even admit uncertainty, questioning whether any being, even the gods, can know how creation occurred. The intellectual boldness of acknowledging ignorance within a sacred text illustrates a distinctive approach. Myth here shades into philosophical speculation, anticipating later Indian schools such as Samkhya, which posited a primordial property, matter, evolving into differentiated elements. The Norse Völuspá, recorded in the Poetic Edda around the 13th century but preserving much older oral traditions, situates creation in Ginnungagap, a yawning void flanked by realms of ice and fire. Their collision generates Ema, the proto-being whose dismembered body becomes the material substrate of the cosmos. The structural similarity to the Enuma Elish, world as corpse, suggests a widespread motif where the sacrifice or destruction of a primal being explains both the origin and the composition of matter. Modern cosmology approaches the question of creation from a radically different perspective, yet the intellectual impulse is identical: to reconstruct how structured existence emerged from a prior state. Observations made by Edwin Hubble at Mount Wilson Observatory in 1929 revealed that distant galaxies exhibit redshifts proportional to their distance, indicating expansion of space itself. This discovery provided empirical foundation for what became known as the Big Bang model, first mathematically formulated by Georges Lemaitre, a Belgian priest and physicist, who in 1927 proposed the idea of a primeval atom from which the universe expanded. Subsequent detection of the cosmic microwave background radiation by Arno Penzias and Robert Wilson in 1965 at Bell Laboratories offered compelling evidence that the observable universe originated in a hot, dense state approximately 13.8 billion years ago. The Big Bang theory replaces the mythic void with a singularity where physical laws, as currently understood, cease to operate. Instead of gods dismembering one another, it posits quantum fluctuations and the rapid inflationary expansion first proposed by Alan Guth in 1981 to account for uniformity across cosmic horizons. The shift in explanatory mechanism is absolute, yet the structural similarity to mythic accounts remains striking. Both narratives describe order emerging from disorder, structure from unformed potential. Where Tiamat's body became heaven and earth, the Big Bang singularity evolved into galaxies, stars, and planets through processes of nucleosynthesis and gravitational collapse. It is instructive to note the persistence of metaphor in both domains. Even within scientific literature, descriptions of the early universe rely on language of birth, emergence, and unfolding. Inflation is described as an epoch, nucleosynthesis as a primordial event, echoing the temporal scaffolding that myths once provided. The necessity of metaphor underscores a cognitive limit. Human language must render abstract processes into intelligible form, and myth provided the first vocabulary for that effort. What distinguishes modern cosmology is its dependence on precise instrumentation and quantitative modeling. Radio telescopes, spectrographs, and particle accelerators generate data that can be compared against predictions of general relativity or quantum field theory. Yet even here, areas of uncertainty remain, such as the role of dark matter and dark energy, which together constitute approximately 95% of the universe's content yet remain undetected directly. The unknowns preserve a space where explanatory frameworks remain provisional, echoing the Rigvedic recognition that origins may be beyond certain knowledge. The interplay between myth and science becomes most visible when considering how societies integrate these narratives into collective identity. Creation myths anchored calendars, rituals, and political legitimacy. Cosmological models today underpin research agendas, funding priorities, and even philosophical speculation about multiverses or the anthropic principle. The scale has changed, but the human drive to situate existence within a larger framework has not diminished. Yet every cosmology, whether mythic or scientific, encounters a threshold where explanation strains against mystery. For Mesopotamians, it was the unknowable abyss before Apsu and Tiamat. For modern physics, it is the Planck epoch where space-time itself loses definable structure. The persistence of such thresholds suggests that explanatory systems may always contend with an irreducible margin of uncertainty, a condition that ensures inquiry never exhausts its subject. The question of the Earth's form posed one of the most enduring challenges for early thought. Before systematic observation, cultures created images of the planet's structure that anchored religious cosmologies, political authority, and practical orientation. These models varied widely, but all sought to impose intelligibility upon the vast surface under human feet and the heavens that surrounded it. Mesopotamian tablets from the 1st millennium BCE, such as the Babylonian world map preserved in the British Museum, depict a flat disk encircled by a cosmic ocean. The central portion represents the known land of Mesopotamia, while triangular regions beyond the encircling waters gesture toward imagined realms of mystery. This configuration not only reflected a limited horizon of geographic knowledge, but also provided a psychological map. The world was stable, bounded, and comprehensible. Within this framework, rivers, mountains, and cities became fixed points in a cosmos ordered by divine decree. In South Asia, mythological accounts situated the earth upon great animals. The concept of the world turtle, known as Kurm in Hindu tradition, places the planet upon the back of a turtle supported by elephants. This image, elaborated in Puranic literature, represents not a naive attempt at geology, but a symbolic device for explaining stability. The weight of mountains and oceans required some foundation, and the image of a vast creature gave intelligible form to the otherwise unanswerable question of what sustains the earth. Similar imagery appears in Chinese traditions, where the giant tortoise Ao is said to bear the 4 pillars of the heavens after being slain by the goddess Nuwa. Northern European cosmology in the Norse tradition described the world tree, Yggdrasil, whose roots and branches held together the 9 realms of existence. The earth was not conceived as a sphere, but as part of a vast organic structure nourished by cosmic waters and threatened by serpents beneath its roots. These images organized experience by embedding human settlement into a larger, stable organism. Mountains, rivers, and seas could be understood as parts of an overarching living whole, linking cosmology to ecological awareness. Practical geography gradually introduced pressure on these symbolic frameworks. Egyptian surveyors during the Middle Kingdom, circa 2000 BCE, employed rope-stretching techniques to measure fields after Nile floods, establishing precise geometric relations between land and water. Greek colonization around the Mediterranean required navigational accuracy that pushed speculation beyond myth. By the 6th century BCE, thinkers in Ionia began to articulate alternative models. Anaximander of Miletus described the earth as a free-floating cylinder, stable not because it rested upon animals or pillars, but because it was equidistant from everything around it. This formulation marked a departure from mythic imagery. Stability arose from symmetry, not divine creatures. By the 4th century BCE, Greek philosophers refined the idea of a spherical earth. Pythagorean schools argued for sphericity on aesthetic grounds, claiming the sphere represented the most perfect form. More persuasive evidence came from Aristotle, who in De Caelo pointed to the curved shadow of Earth observed during lunar eclipses and the disappearance of ships' hulls before their masts on the horizon. These arguments reveal a methodological shift. Mythic images gave way to observational inference. The Earth was no longer held up by animals but suspended in space, its form deduced through empirical evidence. Eratosthenes of Cyrene, chief librarian at Alexandria in the 3rd century BCE, advanced this shift by calculating the Earth's circumference. Observing that at Syene, modern Aswan, the sun at summer solstice cast no shadow in a well, while in Alexandria it cast a measurable angle of about 7.2 degrees, he deduced that the Earth's surface curved. By measuring the distance between the two cities and applying geometric reasoning, he estimated the Earth's circumference at roughly 39,375 kilometers, astonishingly close to the modern value of 40,075 kilometers. The accuracy of his calculation illustrates how quickly mythic images could be replaced by precise measurement once systematic methods were applied. Yet such insights remained localized. In many societies, flat Earth cosmologies continued to dominate. Medieval European manuscripts, such as the T.O. maps of Isidore of Seville in the 7th century, portrayed the world as a circular disk divided into 3 continents, centered on Jerusalem. These maps served theological purposes rather than navigational ones, embedding salvation history into geographic representation. Similar symbolic geography appears in Buddhist cosmology, where Mount Meru stands at the universe's center, encircled by oceans and continents in concentric patterns. These models did not collapse under empirical contradiction because their function was not predictive but integrative, binding cosmology, ritual, and identity. Empirical challenges eventually intensified through maritime expansion. By the 15th century, Portuguese voyages down the African coast required accurate reckonings of latitude and longitude. Instruments such as the astrolabe and cross-staff enabled sailors to measure angular distance from the horizon to the sun or stars, reinforcing the spherical model. The circumnavigation of the globe by Ferdinand Magellan's expedition, 1519 to 1522, provided experiential confirmation that a ship could traverse continuously around the planet, returning to its point of departure from the opposite direction. The persistence of flat Earth imagery into modern periods illustrates the tenacity of symbolic frameworks. Popular imagination often clings to images that organize meaning, even when contradicted by data. The persistence of the world turtle in folklore, or the symbolic centrality of Mount Meru in Buddhist ritual demonstrates that mythic models continue to serve cultural and psychological needs distinct from scientific accuracy. What emerges across these examples is not a simple transition from error to truth, but a spectrum of explanatory strategies. Myths stabilized communities by embedding geography within divine or organic structures. Empirical observation gradually reframed the Earth as an object subject to measurable laws. Yet the two approaches overlapped for centuries, coexisting in maps, rituals, and texts. Even as Eratosthenes calculated circumference with remarkable precision, symbolic cosmologies continued to dominate much of Eurasia. The question of Earth's form illustrates the deeper tension between meaning and measurement. For myth, the Earth's stability had to be justified by creatures, pillars, or trees. For science, it became a matter of geometry, optics, and planetary motion. Yet stability itself remained a central concern. How such stability related to larger celestial cycles would become a new field of inquiry, as the movements of the Sun compelled explanations that reached beyond terrestrial form into the structure of the heavens. The Sun, more than any other celestial body, compelled both reverence and speculation. Its daily rising and setting, its warmth and its absence, its seasonal variations in strength, all of these phenomena touched directly on human survival. Agriculture, migration, and health depended on its cycles, and so cultures across the world developed mythological structures that both explained and sacralized its power. In many of these traditions, the Sun was not a passive object but an active deity, whose will and vitality sustained the natural order. Egyptian religion illustrates this with particular clarity. The solar deity Ra was imagined traversing the sky in a bark by day and journeying through the underworld by night, battling the serpent Apophis to ensure dawn's return. This image conveyed not only cosmological structure but also reassurance of cosmic stability. The victory of light over darkness guaranteed the renewal of life. Egyptian priests at Heliopolis developed an entire theology around solar cycles, integrating them into the regulation of temples, festivals, and kingship. The pharaoh, regarded as the son of Ra, embodied the sun's sustaining force in political form. The orientation of monumental architecture, such as the alignment of Karnak's axis with the solstitial sunrise, indicates how religious cosmology was inseparable from astronomical observation. In Mesoamerica, the Aztec conception of Tonatiuh, the fifth sun, underscored the precariousness of existence. The Aztecs believed that previous suns had perished in cosmic catastrophes, and that the current age required nourishment through human sacrifice to ensure its continuation. This mythic structure is intertwined with empirical observation. Solar eclipses, droughts, and irregular harvests were experienced as evidence of the sun's fragility. Ritualized offerings served as a mechanism to stabilize what was perceived as an unstable cosmic force. The central placement of the sunstone in Tenochtitlan demonstrates that solar cycles were not abstract theology, but the axis around which calendrical and agricultural systems revolved. Greek tradition associated the sun with Helios, who drove his chariot across the heavens, later conflated with Apollo in classical literature. Beyond myth, however, Greek thinkers began to approach the sun as a physical body. Anaxagoras, in the 5th century BCE, argued that the sun was not a divine chariot, but a fiery stone larger than the Peloponnesus. This assertion, preserved in fragments, marks one of the earliest recorded attempts to describe the sun as a natural rather than supernatural entity. His views were met with charges of impiety, illustrating how closely cosmological speculation remained bound to religious orthodoxy. Yet the intellectual trajectory had shifted. The sun could be measured, not merely worshipped. Seasonal change offered another avenue of inquiry. The recognition that the sun's path across the sky, altered over the course of the year, was encoded in structures across the world. Stonehenge in Britain, erected between 3000 and 2000 BCE, aligns its axis with a midsummer sunrise, functioning as a monumental calendar. Similar solar alignments appear in Nabta Playa in southern Egypt, where stone circles from the 5th millennium BCE may have tracked solstitial points. These sites indicate that human communities did not merely mythologize the sun, but observed its cycles with precision sufficient to anchor agriculture and ritual. The connection between solar observation and agriculture is further documented in ancient Mesopotamia, where priest astronomers of Babylon maintained records of solstices and equinoxes. These observations contributed to the development of the lunisolar calendar, which coordinated planting and harvest with celestial cycles. Clay tablets from the Mul-Apen series, circa 1000 BCE, provide systematic listings of rising and setting times of constellations, intertwined with solar motion. Such data were essential for predicting seasonal floods and guiding state-level agricultural planning. Myth and observation coexisted. Solar deities explained causation, while careful measurement allowed prediction. Advances in optics much later allowed for quantitative study of the sun. In 1610, Galileo Galilei directed his telescope at the solar disk, documenting sunspots in letters to Mark Welser. His observations contradicted Aristotelian cosmology, which held that heavenly bodies were perfect and unchanging. By charting the motion of sunspots across the solar surface, Galileo inferred that the sun rotated on its axis approximately once every 27 days. This discovery transformed the sun from an eternal emblem of perfection into a dynamic, evolving object, subject to natural processes. Subsequent investigations revealed the sun's influence on terrestrial phenomena. In 1801, the German chemist Johann Wilhelm Ritter discovered ultraviolet radiation, demonstrating that the sun emitted energy beyond visible light. In the mid-19th century, Heinrich Schwab identified an approximately 11-year cycle in sunspot activity, later confirmed by Rudolf Wolff through systematic counting. The solar cycle proved to influence geomagnetic storms, auroras, and radio communications, binding solar physics directly to earthly technology. Myth had long associated solar irregularity with instability. Scientific measurement provided the mechanism by which such fluctuations affected the planet. The 20th century brought decisive insights into the sun's internal structure. Spectroscopic analysis by Cecilia Payne-Gaposchkin in her 1925 doctoral thesis established that hydrogen is the dominant element in stellar atmospheres, overturning prior assumptions that stars resembled Earth in composition. Later work by Hans Bethe in the 1930s clarified that the sun's energy arises from nuclear fusion of hydrogen into helium in its core, releasing energy according to Einstein's equation. Equals 2. E equals mc 2. This mechanistic account displaced myth entirely from the explanatory domain, yet the symbolic aura of the sun as source of life persisted in cultural imagination. Even with such advances, the sun remains a frontier of unresolved inquiry. The precise mechanisms driving coronal heating to millions of degrees, far hotter than the solar surface, remain subjects of active investigation. Space missions such as NASA's Parker Solar Probe, launched in 2018, approach within a few million kilometers of the Sun to measure plasma flows and magnetic fields. Data from these missions may clarify how solar wind is accelerated and how it shapes the heliosphere, but the processes are still incompletely understood. The tension between symbolic significance and empirical mystery ensures that the Sun continues to inspire as well as puzzle. Its role in sustaining agriculture, technology, and climate renders it both an object of worship in the past and a subject of cutting-edge physics in the present. Yet its variability, cycles of sunspots, flares, and coronal mass ejections, remains a source of vulnerability. The same star that nourishes life also threatens disruption, leaving human inquiry caught between reverence for its constancy and apprehension at its instability. Where the Sun imposed order through its overwhelming brilliance and seasonal cycles, the Moon carried a different kind of influence, softer, shifting, yet deeply embedded in human perception of time and change. Its phases structured calendars, guided nocturnal activities, and inspired mythologies that linked its waxing and waning to fertility, mortality, and the rhythms of the body. Unlike the Sun, which resisted the naked eye's scrutiny, the Moon displayed visible variation over the course of weeks, making it an accessible subject for observation but also fertile ground for mythic imagination. Many early traditions personified the Moon as a goddess associated with fertility and reproduction. In Mesopotamia, Nanasin embodied lunar power, his cycle tied directly to the agricultural calendar and to human reproduction. In Greece, the goddess Selene represented the full moon, while Artemis and Hecate were associated with its crescent and dark phases, reflecting the tripartite division of womanhood: maiden, mother, and crone. In India, Chandra was connected to the nourishing power of Soma, the ritual drink of immortality, his phases linked to cycles of consumption and renewal. Anthropological studies across multiple cultures reveal persistent associations between the lunar month and the average duration of the human menstrual cycle, reinforcing the perception of the Moon as a regulator of life's generative processes. Eclipses magnified the sense of lunar mystery. For many societies, the sudden darkening of the Moon was interpreted as a cosmic struggle. In China, early records describe eclipses as the result of a celestial dragon devouring the Moon, a myth that carried ritual consequences. Banging drums and firing arrows skyward were believed to drive away the creature. Similar themes appear in the Hindu myth of Rahu, a severed head of a demon who periodically swallows the sun or moon before the light re-emerges. Such interpretations framed eclipses not as predictable astronomical events, but as disruptions of cosmic order requiring communal intervention. Despite the mythic framing, systematic observation of lunar cycles emerged early. The Babylonians, with their tradition of astronomical diaries spanning centuries, recognized the periodicity of eclipses through the Saros cycle, approximately 18 years and 11 days, allowing them to predict such events with notable accuracy. These records illustrate how myth and empirical measurement could coexist. While myths offered causal explanations, data provided predictive power essential for maintaining the authority of priestly astronomers. The connection between the moon and tides offered another domain of inquiry. Ancient Greek writers such as Pytheas of Massolia in the 4th century BCE noted the correlation between the phases of the moon and the rising and falling of sea levels along Atlantic coasts. Pliny the Elder in his Natural History described tides as following the moon's orbit, though the precise mechanism was unknown. The gravitational explanation would not emerge until Isaac Newton's Philosophiae Naturalis Principia Mathematica in 1687, where he demonstrated that lunar gravity acts upon Earth's oceans, producing cyclical patterns of high and low water. Before Newton, the association was recognized but lacked physical grounding, leaving the moon's influence suspended between mythic intuition and scientific speculation. Observation of the moon's surface brought another transformation. In 1609, Galileo Galilei turned his telescope toward it, recording mountains, valleys, and craters in his Sidereus Nuncius. His drawings shattered the Aristotelian conception of celestial perfection, revealing the Moon as a body marked by irregularities similar to Earth. The impact of these observations was profound. The Moon was no longer an ethereal goddess or flawless sphere, but a physical world, subject to the same processes of formation and erosion as terrestrial landscapes. This recognition paved the way for later hypotheses about lunar origin. In the late 19th century, George Darwin proposed the fission theory, suggesting the Moon was once part of Earth and separated due to rapid rotation. In the 20th century, alternative theories emerged. The capture theory, in which the Moon formed elsewhere and was gravitationally seized, and the co-accretion theory, positing that Earth and Moon condensed simultaneously from the same disk of material. The currently dominant giant impact hypothesis, developed in the 1970s, proposes that a Mars-sized body, often called Theia, collided with the proto-Earth around 4.5 billion years ago, ejecting debris that coalesced into the Moon. Geochemical analysis of lunar rocks returned by Apollo missions between 1969 and 1972, showing isotopic similarities between Earth and Moon, supports this scenario. Here, what myth once described as divine creation or cosmic struggle became reframed through impact modeling, isotope ratios, and high-temperature simulations. Even with sophisticated models, the Moon retains aspects of mystery. Its exact role in stabilizing Earth's axial tilt, critical for maintaining relatively stable climates over geological timescales, remains a subject of dynamic modeling. Without the Moon, Earth's tilt might vary chaotically, producing climate instability detrimental to complex life. Its retreat from Earth, measured today at 3.8 centimeters per year through laser ranging experiments initiated by reflectors placed during Apollo missions, raises questions about the long-term evolution of Earth-Moon dynamics. The Moon continues to embody a paradox. It is both the nearest celestial body, studied with extraordinary precision, and a source of enduring symbolic resonance. It regulates tides, anchors calendars, and stabilizes planetary motion, yet it is also the site of persistent cultural imagination, from myths of lunacy and madness to modern poetic symbolism. Its phases, eclipses, and surface features still exert an influence far beyond the domain of physics. Even with the wealth of data gathered from lunar missions, including detailed topographical mapping by the Lunar Reconnaissance Orbiter, unanswered questions remain concerning its interior composition, the presence of water ice in permanently shadowed craters, and its role in delivering volatiles to Earth in early planetary history. These gaps in knowledge ensure that the Moon, despite being charted with laser precision, continues to pull human inquiry into unresolved territory. Its nightly presence, shifting and impermanent, remains both a clock in the sky and a reminder of the limits of human understanding. Beyond the Sun and Moon, the night sky revealed a multitude of points whose positions shifted only gradually across human lifetimes. Their apparent permanence contrasted with the regular cycles of the Sun and Moon, creating a canvas upon which cultures projected stories of ancestry, morality, and destiny. These constellations served not merely as ornament or narrative devices, but as practical instruments for navigation, timekeeping, and orientation. The mythological dimension offered cohesion, while the observational discipline transformed stellar patterns into tools of survival and measurement. In ancient Mesopotamia, some of the earliest star catalogues appear on clay tablets dated to the 2nd millennium BCE, including the MUL.Appin series. These texts list rising and setting times of stars and constellations, linking them to agricultural seasons and ritual calendars. The constellations of Orion, the Pleiades, and Taurus were not only mythic figures but also indicators of planting or harvest. The heliacal rising of the Pleiades, for example, corresponded with seasonal transitions across multiple civilizations. What began as narrative, Orion the Hunter, the seven sisters pursued across the sky, carried encoded agricultural instruction vital for sustaining societies dependent on predictable cycles. Egyptian astronomers likewise integrated stellar observation into ritual and architecture. The so-called decans, groups of stars rising consecutively throughout the night, were used to construct a sidereal clock, dividing the nocturnal hours with remarkable accuracy. The alignment of the pyramids at Giza toward Orion's belt and the circumpolar stars demonstrates that stellar patterns were more than symbolic. They regulated monumental construction and legitimized political authority by aligning earthly structures with celestial order. Greek thinkers introduced a more systematic framework for constellations. The poet Aratus, drawing on earlier work by Eudoxus of Cnidus, composed the phenomena in the 3rd century BCE, a text describing constellations and their positions across the sky. Though poetic in form, it represents a catalogue of observational astronomy, mapping human mythologies onto geometric relations in the heavens. Hipparchus, working in the 2nd century BCE, advanced the discipline further by compiling a star catalogue of over 800 entries, noting positions with unprecedented accuracy. His discovery of the precession of the equinoxes, a slow, approximately 26,000-year wobble in Earth's axis, illustrated that even the apparently immutable stars shifted over long timescales. The discovery undermined the myth of fixed celestial order and introduced a deeper temporal dimension to the heavens. China developed its own system of stellar cartography, independent from the Mediterranean tradition. Records from the Shih and later the Tang dynasty star maps show a sky divided into asterisms reflecting imperial bureaucracy, with the celestial equator partitioned into 28 mansions. This organization provided not only astronomical orientation but also a symbolic mirror of earthly governance, embedding dynastic legitimacy within the structure of the cosmos. Systematic observations recorded in texts like the Book of Han include early accounts of supernovae, such as the explosion visible in 185 CE, demonstrating that Chinese astronomers were attentive not only to patterns but to anomalies that disrupted them. Polynesian navigation offers another example of the practical application of stellar knowledge. Across vast stretches of ocean, voyagers memorized star paths, sequences of rising and setting stars aligned with the horizon at particular latitudes, to guide canoes across thousands of kilometers without compasses or maps. The stories associated with these stars preserved the sequences as oral knowledge, transforming mythology into a mnemonic device. The Polynesian star compass remains one of the most striking illustrations of how constellations functioned simultaneously as myth, art, and precise scientific tool. The Islamic Golden Age expanded the scope of stellar science through translation and extension of Greek works. Al-Sufi's Book of Fixed Stars, 964 CE, provided detailed illustrations and descriptions of constellations, comparing Greek and Arab traditions while correcting positional data. His text became a reference for centuries, bridging mythological imagery with systematic measurement. The work of later scholars such as Ulu Beg in Samarkand, who compiled a star catalogue of nearly 1,000 entries in the 15th century using a massive sextant, exemplifies how mythic patterns could coexist with rigorous mathematical astronomy. European advances in the Renaissance integrated stellar catalogues with navigational technology. Tycho Brahe's detailed measurements of star positions using large quadrants and sextants without telescopes achieved an accuracy unprecedented for the pre-telescopic era. His data, later utilized by Johannes Kepler, provided the empirical foundation for the discovery of planetary elliptical orbits. Constellations in this context were less about narrative than about precise spatial coordinates, yet the mythic names persisted, revealing how deeply cultural imagination remained entangled with scientific representation. The invention of the telescope expanded stellar study into new domains. Galileo's observations revealed the Milky Way to be composed of innumerable faint stars, collapsing the mythic idea of it as a singular celestial river. Later, William Herschel in the 18th century undertook systematic star counts, producing a rudimentary model of the Milky Way's structure. These efforts reframed the constellations from bounded mythological figures into nodes of a vastly larger stellar system, yet the human eye continued to organize the sky into familiar patterns. The 19th and 20th centuries introduced spectroscopy, transforming starlight into a source of chemical and physical data. Joseph von Fraunhofer's identification of dark absorption lines in solar and stellar spectra revealed that stars shared elements with Earth, erasing the Aristotelian separation of terrestrial and celestial matter. Subsequent work by Cecilia Paine-Gaposchkin in 1925 demonstrated that hydrogen and helium dominated stellar composition, a discovery that altered the fundamental understanding of stars. Constellations, once mythic hunters or maidens, became frameworks for locating objects whose light could be decomposed into elemental signatures. Modern astrophysics continues to operate with constellational boundaries, codified by the International Astronomical Union in 1922 into 88 official regions of the sky. These divisions are not mythic in function but administrative in necessity, yet the ancient names remain: Orion, Scorpius, Andromeda. The persistence of these designations highlights the enduring entanglement of myth and measurement, even in an era defined by space telescopes and digital surveys. Despite the wealth of data from missions such as Gaia, which maps stellar positions and motions with micro-arcsecond precision, constellations retain symbolic power. They are employed in horoscopes, art, and national symbols, carrying meanings independent of astrophysical reality. This duality persists because human cognition seeks patterns, and stories grafted onto stars continue to satisfy a psychological need. Yet the stars themselves reveal irregularities: supernovae, pulsars, variable stars, that resist static patterning, drawing attention away from mythic permanence toward dynamism and instability. The constellations, once navigational guides and sacred stories, are now portals into stellar physics and galactic structure. Yet even as science expands the scale of understanding, the patterns persist in human imagination, ensuring that the night sky remains both a scientific laboratory and a cultural text. The regularity of the stars invites order, but their occasional disruptions hint at forces still incompletely understood, unsettling the very stability they once symbolized. Where stars and planets offered the appearance of permanence, storms confronted early societies with sudden violence, unpredictable in onset and devastating in consequence. Thunder, lightning, torrential rain, and destructive winds shattered the assumption of stability that mythic cosmologies sought to impose. In response, cultures fashioned deities of storm and sky, figures whose anger or favor appeared to govern the most immediate of atmospheric phenomena. The terror inspired by storms ensured that these myths carried an intensity absent from more distant celestial narratives. In the Norse tradition, Thor embodied thunder's force. His hammer, Mjolnir, hurled across the heavens, produced lightning and thunderclaps. Ritual accounts suggest that offerings were made to Thor to protect harvests and dwellings from destructive storms. The link between weapon and thunder emphasized power and violence, a physical blow translated into a natural event. In Greek mythology, Zeus occupied a similar role, wielding the thunderbolt as both weapon and symbol of supreme authority. The lightning strike, unpredictable and deadly, functioned as divine judgment. In Vedic India, Indra fulfilled this role, his Vajra striking serpents that obstructed rivers, releasing rainfall essential for crops. These deities were not abstract cosmological figures, but explanations of meteorological violence expressed through anthropomorphic will. Despite the mythological framing, empirical attempts to record atmospheric phenomena appeared early. Aristotle's Meteorologica, circa 340 BCE, compiled observations on winds, clouds, rainbows, and thunder. Though couched within the framework of four-element theory, Aristotle sought natural causes rather than divine agency. He suggested that lightning resulted from the rapid ignition of dry exhalations within clouds, while thunder was the noise of air being displaced. Although inaccurate in mechanism, this represented an attempt to shift storms into a domain of natural philosophy, where explanation did not require personification. His work would dominate European meteorology for nearly 2 millennia, a testimony to the authority of systematization even when error persisted. Chinese traditions combined mythic and empirical approaches. texts from the Han Dynasty record observations of unusual lightning phenomena, including descriptions of ball-like forms resembling what modern accounts call ball lightning. At the same time, storm gods such as Lei Gong, the drum-beating deity of thunder, remained central in ritual practice. The coexistence of meticulous recording and divine interpretation illustrates how atmospheric unpredictability encouraged explanatory pluralism. Systematic experimentation with electricity in the 18th century transformed these phenomena from myth into measurable force. Benjamin Franklin's kite experiment in 1752 demonstrated that lightning was electrical in nature. By flying a kite during a thunderstorm with a metal key attached to its string, Franklin observed sparks that could be drawn from the key. His findings, published in the Transactions of the Royal Society, provided evidence that the same force powering laboratory electrostatic devices operated in storms. The lightning rod, invented shortly afterward, became a practical application of this discovery, protecting structures by channeling electrical discharges safely into the ground. Here the transition from divine weapon to physical discharge reshaped human relationship with storms. Not only could they be explained, they could be managed. The 19th century deepened the investigation. Michael Faraday's research on electromagnetic induction in the 1830s and James Clerk Maxwell's equations in the 1860s revealed electricity and magnetism to be unified forces, obeying mathematical laws. Lightning became an expression of charge separation within thunderclouds, a consequence of interactions between ice crystals, water droplets, and updrafts that created large potential differences. Experiments by C.T.R. Wilson in the early 20th century, using cloud chambers, clarified the ionization processes that accompany high-voltage discharges, linking microphysical processes to the macroscopic violence of storms. Modern meteorology, supported by radar, satellites, and supercomputing, investigates storms at scales unimaginable to earlier societies. Doppler radar reveals the internal rotation of supercells, precursors to tornadoes. Lightning detection networks triangulate the location of discharges worldwide in real time, generating global maps of electrical activity. High-speed cameras capture stepped leaders and return strokes, confirming that lightning propagates in discrete bursts rather than continuous flows. The mysteries once attributed to gods now unfold as measurable events shaped by thermodynamics and fluid dynamics. Yet even with advanced instrumentation, storms retain elements of unpredictability. Forecast models struggle to capture the precise initiation of severe thunderstorms or the exact path of tornadoes. Ball lightning, reported for centuries, remains poorly understood, with hypotheses ranging from plasma vortices to silicon combustion, none conclusively demonstrated. The sheer energy involved in a single lightning bolt, releasing on average 500 megajoules, enough to power a small town for hours, reminds researchers that storms are not fully tamed phenomena but active frontiers of physics. The cultural resonance of storm myths persists alongside scientific understanding. Lightning remains a symbol of power in literature and national emblems. The personifications of Zeus, Thor, and Indra continue to appear in popular culture, embodying awe-before forces that, though scientifically explicable, retain emotional intensity. The continuity suggests that myth and science serve distinct functions, one providing causal mechanism, the other encoding emotional experience. The study of storms underscores a broader theme in the history of natural science. Phenomena initially personified as divine acts often reveal themselves as processes governed by physical laws, yet the transition does not erase the sense of wonder. Each discovery generates new layers of complexity, extending inquiry into atmospheric electricity, climate dynamics, and planetary meteorology. Lightning has been observed on Jupiter and Saturn, captured by spacecraft cameras, reminding researchers that the forces once associated with gods of Earth belong to universal physical processes. Despite centuries of study, the atmosphere continues to present questions without definitive answers. The initiation of lightning strokes, the role of cosmic rays in discharge processes, and the feedback loops between storms and global climate remain areas of active research. Each unresolved element ensures that storms remain not only objects of fear and myth, but also catalysts of continuing scientific investigation, pushing explanation into domains where uncertainty still dominates. Few natural forces inspired deeper dread than the trembling of the ground beneath human settlements or the sudden eruption of fire from mountains. Unlike storms, which could be anticipated by clouds or shifting winds, earthquakes and volcanic outbursts arrived with little warning, often destroying entire cities in moments. The apparent randomness of such events led ancient societies to imagine subterranean creatures, imprisoned gods, or cosmic punishments as causes. These explanations, though mythological in form, emerged from genuine attempts to account for phenomena that challenged the very assumption of stability on which daily life depended. Japanese folklore described earthquakes as the thrashing of Namazu, a giant catfish restrained beneath the islands by the god Kashima with a heavy stone. When the deity's vigilance lapsed, Namazu would writhe, shaking the land. This narrative offered both explanation and moral lesson. Vigilance must be maintained to prevent catastrophe. In Greek tradition, Poseidon bore the epithet Enosigaios, earth-shaker, wielding the trident that could fracture the ground. Such personifications conveyed a recognition that forces beneath the Earth's surface could rupture the built environment, but lacking geophysical models, these societies attributed agency to familiar divine figures. Volcanoes received similar mythological treatment. The Romans believed that Vulcan, god of fire, worked his forge beneath Mount Etna, sparks and molten streams being the evidence of his labors. In Polynesian myth, the goddess Pele resided in Kilauea, her eruptions expressing passion and wrath. These figures localized explanation. A mountain became the dwelling of a deity, its violence the manifestation of personal emotion. Such stories provided coherence in landscapes where the ground itself seemed capable of betrayal. Early natural philosophers sought alternative frameworks. Aristotle proposed that winds trapped within subterranean caverns caused earthquakes, with tremors produced when these winds struggled to escape. Strabo, writing in the 1st century CE, expanded on this by suggesting that volcanic eruptions resulted from underground fires ignited by these exhalations. Though inaccurate, these models show an effort to move explanation from divine agency to physical process. Theories of subterranean vapors persisted into the Renaissance, illustrating how long intellectual traditions can survive even in the absence of empirical confirmation. Systematic documentation of earthquakes began in Imperial China. The polymath Zhong Hang constructed an instrument in 132 CE, often described as the first seismoscope. A large bronze vessel, it contained 8 dragon heads, each holding a ball. When a distant earthquake occurred, one ball would drop into the mouth of a corresponding toad, indicating the direction of the disturbance. Although the mechanism's details remain debated, contemporary records claim it successfully detected earthquakes hundreds of kilometers away. This device represents an extraordinary leap. Seismic events were no longer mere expressions of myth, but phenomena capable of being recorded and analyzed. Volcanic eruptions left records equally vivid. The eruption of Vesuvius in 79 CE, which buried Pompeii and Herculaneum, was described by Pliny the Younger in letters to Tacitus. His accounts detail the column of ash rising into the sky, the darkness at midday, and the raining pumice that suffocated towns. Modern volcanology uses the term Plinian eruption to describe explosive events of similar scale, linking ancient eyewitness narrative to contemporary scientific classification. The integration of descriptive detail with later geophysical models illustrates how systematic observation, even without instrumentation, can produce enduring categories of knowledge. The Enlightenment period introduced quantitative approaches. John Michel, an English natural philosopher, in his 1760 treatise Conjectures concerning the cause and observations upon the phenomena of earthquakes, argued that quakes propagated as waves through elastic materials, a concept remarkably close to modern seismology. He also suggested that the direction of travel could be inferred from observational data collected across multiple sites, anticipating methods later formalized with seismographs. Michel's insights reveal the gradual shift toward treating seismic events as measurable disturbances propagating through Earth's interior rather than capricious divine acts. Instrumentation advanced rapidly in the 19th century. Luigi Palmieri, working at the Vesuvius Observatory in the 1850s, developed electromagnetic seismographs that recorded ground movement on smoked glass. His observations linked tremors with volcanic activity, correlating seismic patterns to eruptive behavior. These data provided the foundation for modern seismology, in which waveforms are classified into P waves, S waves, and surface waves, each traveling at characteristic speeds and revealing properties of Earth's interior. The destructive force of earthquakes became a tool for probing planetary structure, converting catastrophe into insight. Plate tectonics in the 20th century provided the unifying model. Alfred Wegener's 1912 theory of continental drift, initially controversial, gained support in the 1960s through evidence of seafloor spreading and global patterns of seismicity. Earthquakes and volcanoes clustered along plate boundaries, where lithospheric slabs collided, diverged, or slid past one another. Subduction zones explained chains of volcanoes such as the Andes and the Japanese archipelago, while transform faults accounted for strike-slip quakes along the San Andreas Fault. What myth had once attributed to gods or monsters became comprehensible as consequences of convection currents in Earth's mantle-driving plates across the globe. Yet predictability remains elusive. Despite dense networks of seismographs and satellites measuring ground deformation with millimeter precision, no reliable method exists for forecasting the exact time and magnitude of major earthquakes. Volcanic eruptions can be monitored through gas emissions, seismic swarms, and thermal anomalies, but their onset and scale resist precise forecasting. The persistence of unpredictability ensures that earthquakes and volcanoes continue to inspire awe and anxiety, much as they did in mythic traditions. Recent decades have introduced new dimensions of inquiry. Deep Earth seismology, using arrays of instruments across continents, probes structures near the core mantle boundary, revealing superplumes and heterogeneities that may influence volcanic hotspots. Remote sensing satellites track ground deformation over active regions, offering early warning for potential eruptions. Yet destructive events such as the 2004 Indian Ocean earthquake and tsunami, or the 2010 eruption of Age of Geological disrupting global air travel, demonstrate how vulnerable modern societies remain. The myths of catfish, serpents, and gods once translated unpredictability into familiar imagery. Science now speaks in terms of stress accumulation, fault rupture, and magma ascent, yet the uncertainty persists. The very processes that shaped continents and created habitable environments continue to resist control, forcing inquiry toward deeper models and more refined instrumentation while leaving communities exposed to sudden upheaval. The ground beneath human feet remains a site of fragile security, subject to forces whose magnitude ensures that explanation and prediction are never complete. Water, indispensable to life, also revealed itself as a force of annihilation when it appeared in excess. Floods erased cities, fields, and histories, leaving behind both destruction and fertile soil. Their recurrence in river valleys and coastal plains etched deep marks into cultural memory. Communities sought explanations in narratives of divine punishment, cosmic reset, or heroic survival, encoding catastrophe into myth while transmitting practical awareness of hydrological cycles. The Mesopotamian epic of Gilgamesh preserves one of the earliest written accounts of a great flood. In Tablet 11, Utnapishtim recounts how the gods resolved to destroy humanity with rising waters, sparing only him and his vessel. The narrative, recorded on clay tablets dating to around 1200 BCE but reflecting far older oral traditions, likely memorializes catastrophic flooding along the Tigris and Euphrates. Geological studies confirm that these rivers frequently overflowed, their floodplains subject to rapid inundation when seasonal rains coincided with snowmelt in upstream mountains. The myth provided theological interpretation, while its preservation ensured cultural memory of disaster and survival strategies. Comparable traditions arose across cultures. The Hebrew account of Noah in the book of Genesis describes 40 days of deluge, the ark resting upon mountains once waters receded. Hindu literature recounts Manu, forewarned by a fish avatar of Vishnu, who builds a boat to withstand cosmic floodwaters. Chinese legend tells of Gun and his son Yu, tasked with taming floodwaters that threaten the Yellow River basin. Yu's efforts to dredge and channel water rather than block it corresponds strikingly with engineering principles later applied in Chinese hydraulic projects. Across continents, flood myths functioned both as moral allegories and as encoded recollections of real environmental crises. The recurrence of such myths reflects more than coincidence. Paleoclimatic research indicates that abrupt climatic events, such as the melting of glacial lakes during the Holocene, produced large-scale floods. The Black Sea deluge hypothesis, advanced by William Ryan and Walter Pittman in the 1990s, suggests that rising Mediterranean waters catastrophically breached into the Black Sea basin around 5600 BCE, raising its level by dozens of meters. While debated, such hypotheses highlight how regional floods could be magnified into enduring cosmological narratives, their local devastation transmuted into universal resets of creation. Scientific understanding of floods emerged from attempts to regulate rivers for agriculture. The Nile's annual inundation, predictable yet variable in intensity, structured Egyptian civilization. Nilometers, stone staircases marked with measurement inscriptions, allowed priests to track water levels with precision from at least the 2nd millennium BCE. Records show that water levels between 16 and 18 cubits were optimal. Too low threatened famine, too high risk destruction of dikes and fields. The measurements, though embedded within religious ritual, represent early hydrological monitoring systems. In China, hydraulic engineering developed in response to the volatile Yellow River, known as China's Sorrow, for its frequent catastrophic floods. Records from the Zhou and Han dynasties detail projects involving levees, dredging, and diversion channels. The Dujiangyan irrigation system, constructed in the 3rd century BCE, diverted waters of the Min River, reducing flood risk while expanding arable land. Its enduring function testifies to how societies, while embedding floods in myth, also developed technical strategies grounded in empirical observation of water behavior. European natural philosophers in the Renaissance began to frame floods within the broader water cycle. Bernard Palissy, a French potter and naturalist, argued in the 16th century that rainfall replenished rivers, rejecting theories of subterranean oceanic circulation. His observations, based on the infiltration of water into soil and its re-emergence in springs, anticipated hydrological principles later formalized. In the 17th century, Pierre Perrault and Edmé Mariotte conducted systematic measurements of rainfall and river discharge in the Seine basin. Their findings demonstrated quantitatively that precipitation was sufficient to supply river flow, establishing the basis of modern hydrology. The water cycle itself, evaporation, condensation, precipitation, and runoff, emerged as a scientific model through these efforts. Evangelista Torricelli's invention of the barometer in 1643 enabled measurement of atmospheric pressure, advancing understanding of how air and moisture interact. Experiments by Edmund Halley in 1687 estimated the rate of evaporation from the Mediterranean, concluding that atmospheric return flows must balance the loss, a direct challenge to older subterranean ocean theories. These quantitative approaches dismantled mythic interpretations by grounding floods within measurable, repeatable processes of circulation. Yet unpredictability remained. Modern hydrology, equipped with gauging stations, satellite remote sensing, and computational models, still confronts difficulty in forecasting extreme flood events. Climate change intensifies rainfall variability, increasing both drought and flood risk in many regions. Catastrophic events such as the 1931 China floods, which killed an estimated 1 to 4 million people, reveal the limits of human control even with extensive hydraulic infrastructure. Flood myths continue to resonate because they capture the enduring vulnerability of human societies to overwhelming water. Flood narratives also shaped conceptions of moral order. In many traditions, water's destructive power was interpreted as cleansing, resetting human history by eliminating corruption or disorder. This symbolic dimension persists in religious rituals of purification and rebirth through immersion. The material basis, seasonal floods restoring soil fertility, or catastrophic floods erasing entire settlements, combined with symbolic interpretation to create a dual role for water, both life-giver and destroyer. Contemporary science situates floods within broader climatic systems. Ocean-atmosphere interactions such as El Niño, Southern Oscillation influence rainfall patterns across continents, triggering floods in South America and droughts in Asia. Paleoflood hydrology reconstructs prehistoric flood events from sediment deposits, tree rings, and cave speleothems, extending records beyond written history. These methods reveal that floods of magnitudes surpassing modern experience have occurred repeatedly over millennia, reinforcing the cultural memory preserved in myths. Despite advances in hydrology, the capacity to forecast remains limited to probabilistic ranges. Satellite altimetry measures river heights across continents, while numerical weather prediction models simulate rainfall distribution, yet flash floods triggered by localized storms can still overwhelm urban infrastructure without warning. The persistence of uncertainty ensures that the psychological resonance of flood myths remains intact. The interplay of myth, memory, and measurement highlights the dual character of floods. They embody recurring natural processes embedded in hydrological cycles, yet their destructive irregularities keep them charged with existential significance. Each inundation renews the sense of precariousness, reminding societies that beneath the apparent mastery of water management lies a force that resists containment. And as rivers rise beyond their banks and seas encroach on coasts, the question of how humans frame water, whether through myth, science, or both, remains unsettled, demanding new ways of interpreting the cycles that govern survival. Illness confronted early societies with an enigma more intimate than storms or earthquakes. The body, apparently whole one day, could collapse the next under forces invisible to sight. Fever, wasting, convulsions, or sudden death appeared to arise from within, beyond the reach of weapons or walls. The inability to locate a tangible enemy led many cultures to interpret disease as intrusion by spirits, punishment by deities, or the consequence of curses. Healing practices emerged within this framework, combining ritual, herbal remedies, and incantation into systems that served both practical and symbolic purposes. In Mesopotamia, disease was frequently described in terms of demonic assault. Clay tablets from the library of Ashurbanipal, 7th century BCE, preserve incantations against Ashoka demons, believed to cause fevers and wasting illnesses. Priests of the Asapur tradition performed elaborate rituals involving sacrifices, fumigations, and recitations, aimed at expelling the malevolent force. Yet within these rituals, one finds prescriptions of medicinal plants such as licorice, willow, and mustard, substances with pharmacological properties later confirmed by modern pharmacognosy. The symbolic framework justified the practice, while empirical trial and error preserved useful remedies. Egyptian medical papyri, including the Ebers papyrus, circa 1550 BCE, reveal a parallel duality. Illness was sometimes attributed to malevolent spirits or divine displeasure, yet the text contains hundreds of prescriptions based on honey, garlic, resin, and minerals. Honey's antibacterial properties, garlic's allicin content, and resin's antiseptic qualities provide tangible efficacy. Surgical descriptions in the Edwin Smith papyrus extend beyond magic. They include suturing techniques, wound dressings, and anatomical observations, suggesting that empirical healing coexisted with ritual invocations to ward off evil. Greek medicine represents one of the earliest systematic attempts to detach disease from divine causation. Hippocrates, in texts attributed to his school during the 5th and 4th centuries BCE, argued that illness resulted from imbalances of bodily humors: blood, phlegm, yellow bile, and black bile. Though the humoral framework was incorrect in mechanism, it represented a conceptual shift. Disease arose from natural processes subject to regulation, not supernatural attack. Hippocratic physicians prescribed diet, exercise, and controlled bleeding as methods of restoring balance. The authority of this model endured across Europe and the Islamic world for nearly 2 millennia, shaping medical education and practice into the Renaissance. Indian traditions recorded in the Atharva Veda, 2nd millennium BCE, and later in Ayurveda developed a comparable system. Disease was interpreted through disturbances in doshas, vata, pitta, and kapha, representing functional principles of motion, transformation, and cohesion. Texts such as the Charaka Samhita combined ritual mantras with detailed herbal pharmacology, describing plants like neem, turmeric, and ashwagandha, whose bioactive compounds are subjects of modern pharmacological study. Here, too, symbolic cosmology structured the explanatory system, while cumulative empirical experience enriched therapeutic practice. Chinese medicine articulated illness through the lens of imbalance between yin and yang, and later through the circulation of qi along meridians. Acupuncture, first systematically described in the Huangdi Neijing, c. 2nd century BCE, sought to restore harmony through insertion of needles at precise points. While early practitioners justified the technique through cosmological correspondence, contemporary studies suggest that acupuncture modulates neural pathways, endorphin release, and local blood flow, offering physiological effects independent of its symbolic framework. The continuity of practice across millennia illustrates the resilience of explanatory systems when combined with perceived therapeutic outcomes. European medieval medicine absorbed and reinterpreted ancient frameworks. The spread of Galenic humoral theory through Latin translations and Islamic commentaries integrated Greek ideas into Christian cosmology. Illness was often framed as both natural imbalance and divine test, permitting medical intervention alongside prayer and penance. Hospitals, first organized in Byzantine and Islamic contexts, became centers where charity, ritual, and treatment intersected. Islamic physicians such as Avicenna in the Canon of Medicine, 1025, synthesized Greek, Persian, and Arab knowledge, offering diagnostic procedures and pharmacological classifications that remained authoritative into early modern Europe. The scientific reorientation began with the anatomical investigations of Andreas Vesalius in the 16th century, whose De Harmonie Corporis Fabrica corrected Galenic errors through dissection. Yet the decisive transformation in disease theory emerged only with the development of microscopy. Antony van Leeuwenhoek's 17th-century observations of animalcules in water hinted at microbial life, though their pathogenic role was not recognized. It was not until the 19th century that Louis Pasteur and Robert Koch articulated germ theory. Pasteur demonstrated that microorganisms caused fermentation and disease, while Koch identified specific pathogens for anthrax, tuberculosis, and cholera. This redefined illness as invasion by microscopic entities rather than imbalance or divine punishment, providing a testable, mechanistic foundation for medicine. The consequences of this shift were profound. Vaccination, pioneered by Edward Jenner in 1796 with cowpox inoculation against smallpox, gained theoretical justification through germ theory. Antiseptic surgery, developed by Joseph Lister in the 1860s using carbolic acid, dramatically reduced postoperative infections. Public health initiatives, clean water systems, sewage treatment, and quarantine measures acquired scientific legitimacy. Where myth once explained disease as punishment or curse, laboratories now isolated bacteria on agar plates, traced transmission through populations, and designed interventions based on evidence. Yet even as pathogens became identifiable, mysteries persisted. Viruses, invisible to light microscopy, eluded detection until the invention of the electron microscope in the 1930s. Their discovery complicated germ theory by revealing agents that straddled the boundary between life and non-life, incapable of replication without host cells. Treatments required not eradication but modulation of host-virus interactions, a challenge that continues with emerging pathogens. Cultural dimensions of disease never disappeared. Epidemics such as the Black Death in the 14th century or the influenza pandemic of 1918 generated apocalyptic interpretations, even as medical explanations evolved. Social responses, stigmatization, scapegoating, or ritual purification, demonstrated the enduring need to situate illness within frameworks of meaning beyond biology. Myths of punishment or demonic invasion, though displaced from medical science, resurfaced in popular imagination whenever fear exceeded explanatory capacity. Modern medicine combines molecular precision with ancient echoes. Herbal remedies once justified by myth are investigated through randomized controlled trials, revealing compounds such as artemisinin from sweet wormwood, now central in malaria treatment. Practices rooted in symbolic cosmologies, such as acupuncture or yoga, are studied with neuroimaging and physiological monitoring, revealing mechanisms distinct from their original explanations. The interplay between mythic heritage and empirical science continues to shape both research agendas and patient experience. Despite immense progress, disease retains elements of unpredictability. Pathogens mutate, resist drugs, and cross species barriers, generating outbreaks that challenge established systems. The COVID-19 pandemic underscored the fragility of human defenses, reminding societies that invisible agents remain capable of overwhelming health infrastructures. The persistence of uncertainty ensures that disease continues to occupy a space once filled by myth, a reminder that vulnerability is not fully eradicated but only managed. And as science confronts these shifting threats, the dialogue between explanatory frameworks and human fear remains unfinished, pressing inquiry toward deeper understanding of life's fragility. No natural phenomenon shaped human thought more profoundly than death. Unlike storms, floods, or disease, which might be survived, death presented itself as absolute and irreversible. Yet the processes underlying it, decomposition, decay, the transformation of the body, were initially hidden from precise knowledge. Myths of the underworld, resurrection, and judgment arose not merely to offer comfort, but to impose explanatory order upon the apparent cessation of life. These myths became frameworks through which cultures explored both the biology of mortality and the persistence of memory. In Mesopotamian tradition, the underworld was ruled by Ereshkigal, a shadowy realm where the dead dwelt in silence and dust. The descent of Inanna describes the goddess's passage into this realm, where she is stripped of her powers before returning to life. Greek myth located the dead in Hades, divided into regions such as the Elysian Fields for the virtuous and Tartarus for the condemned. Egyptian belief centered on Osiris, whose death and resurrection became the model for human passage into the afterlife, judged by the weighing of the heart against the feather of Marat. Norse cosmology envisioned hell, a realm of cold and shadow for those who died without glory. Each of these traditions transformed the biological inevitability of death into a structured geography, with rules of entry, judgment, and continuation. The natural processes of decomposition were interpreted through these symbolic lenses. Archaeological remains show that burial practices were not simply acts of disposal, but responses to observable physical changes. The swelling of the abdomen, the discoloration of flesh, and the reduction of the body to bone all demanded explanation. In many traditions, these changes were framed as transformations of the soul's status, or as evidence of lingering presence. The smell of decay, produced by compounds such as putrescine and cadaverine, gave rise to associations with impurity and miasma, linking biological breakdown to concepts of spiritual danger. Greek medical writers attempted to describe death as a natural endpoint of bodily processes. Hippocratic texts framed it as the exhaustion of innate heat and moisture, while Galen in the 2nd century CE argued that cessation of pulse and respiration marked the end of vital spirit. These models, though limited, signaled a shift from mythic geographies of the underworld to physiological accounts of what occurred within the body. Yet the inability to observe internal changes beyond external symptoms kept explanations speculative. Religious traditions often incorporated elements of preservation that reflected early encounters with decomposition. Egyptian mummification, developed during the 3rd millennium BCE, employed natron salts to desiccate the body, resins to inhibit microbial growth, and linen wrappings to create a barrier against external agents. While the practice was justified as preparation for eternal life, its success rested on empirical observation that desiccated or resin-treated bodies resisted decay. Similar practices appear in other cultures. Andean mummies preserved in dry mountain climates or bog bodies in northern Europe whose acidic environments inhibited bacterial activity. Myth and ritual framed these practices, but their efficacy relied on natural chemistry. Philosophical speculation on death advanced during antiquity. Plato, in the Phaedo, argued for the soul's immortality, distinguishing between the corruptible body and the eternal essence. Epicurus countered by asserting that death was the dissolution of atoms composing the soul, leaving no consciousness after dissolution. These positions reflected broader debates on whether death represented transformation or cessation. The arguments shaped later theological developments, yet they also reveal an early struggle to reconcile observable decay with metaphysical interpretation. The development of anatomy and physiology in early modern Europe began to strip away the veil of mystery. Andreas Vesalius's dissections in the 16th century revealed structures of the circulatory and nervous systems, suggesting material bases for life functions. William Harvey's demonstration of blood circulation in 1628 reframed death as the irreversible cessation of systemic flow. With the invention of the microscope, Marcello Malpighi in the 17th century observed capillaries and cellular structures, advancing the understanding that life processes operated at levels beyond ordinary sight. Death, in this view, became a failure of organization at multiple scales rather than an immediate transfer of the soul to an underworld. Despite advances, uncertainty persisted regarding the precise moment of death. Premature burial was a recurrent fear in 18th and 19th century Europe, driven by cases of apparent death where individuals later revived. Debates raged over whether absence of heartbeat, respiration, or consciousness constituted the definitive criterion. Claude Bernard's 19th century research on physiology introduced the concept of milieu intérieur, emphasizing the body's equilibrium. Death followed when regulation failed irreversibly. In the 20th century, the definition shifted further with the concept of brain death, formalized in the 1968 Harvard criteria, recognizing irreversible cessation of brain function as the threshold even if circulation could be sustained artificially. Each redefinition reflected advances in technology and understanding, displacing older mythic boundaries with physiological markers. Scientific study of decomposition developed into the discipline of forensic taphonomy. Researchers such as Jean-Pierre Megnin in the 19th century classified stages of decay, from fresh to dry remains, using insect succession as markers. Blowflies, beetles, and other organisms colonized corpses in predictable patterns, allowing estimation of post-mortem interval. What had once been interpreted as spiritual corruption became measurable ecological succession, transforming death into a process governed by biology and chemistry. Yet even with scientific precision, cultural dimensions of death remain deeply embedded. Funeral rituals, beliefs in afterlife, and symbolic geographies of the underworld persist alongside clinical definitions. Neuroscientific research on near-death experiences, with subjects reporting tunnels, lights, and presences, continues to generate debate. Whether these experiences reflect cultural expectation, oxygen deprivation, or altered neural activity is unresolved. The persistence of these accounts underscores that death is not merely a biological event, but a phenomenon demanding meaning at multiple levels. Modern medicine has extended the boundary between life and death, but uncertainty lingers at its margins. Organ transplantation requires precise determination of death, yet disputes over criteria reveal philosophical as well as biological tension. Cryonics, stem cell research, and digital preservation of consciousness raise new questions about whether death is absolute or subject to technological negotiation. The same anxieties that once produced myths of the underworld now reappear in laboratories and courts, framed in scientific rather than mythological terms, but driven by the same impulse to comprehend what lies beyond the cessation of breath. Death, whether imagined as passage into shadow realms or analyzed through cellular breakdown, continues to resist definitive containment. Each attempt at explanation opens further questions about consciousness, identity, and the nature of life itself. And as inquiry presses deeper into biological and technological frontiers, the threshold between life and its absence remains unsettled, drawing thought toward domains where certainty dissolves. The presence of animals in myth was never incidental. They occupied a dual position in human imagination, familiar companions and sources of sustenance, yet also embodiments of powers beyond comprehension. Their behaviors, migration, metamorphosis, nocturnal hunting, hibernation, presented patterns that seemed to transgress ordinary human experience. Myths transformed these observations into stories of beasts, hybrids, and shapeshifters, blending empirical encounters with symbolic frameworks that offered explanations where zoology did not yet exist. Mythological creatures often arose from distorted perceptions of real animals. The griffin, depicted with the body of a lion and the head and wings of an eagle, likely originated from fossil discoveries of protoceratops in Central Asia, whose beak-like skull and crouched posture suggested a hybrid form. Travelers encountering such remains projected them into myth, encoding paleontological traces into symbolic beasts. The unicorn, recorded in Greek and Indian texts, may derive from accounts of the Indian rhinoceros, its single horn exaggerated into purity and incorruptibility. These transformations reveal how myth functioned as protozoology, attempting to rationalize the unfamiliar by folding it into recognizable archetypes. In Native American traditions, animals were often understood as kin or teachers, endowed with transformative powers. The Lakota told of white buffalo calf woman, who brought sacred rituals, emphasizing the buffalo's central role in sustenance. In Amazonian shamanic cosmologies, jaguars were portrayed as beings who could shift between human and animal forms, a symbolic rendering of the predator's power and the hallucinatory visions induced by plant-based rituals. Such stories highlight how ecological dependence and observation of animal behavior fed into symbolic narratives of transformation. Greek mythology provided some of the most elaborate examples of animal transformation, or metamorphosis. Ovid's Metamorphoses catalogued instances where humans became birds, trees, or beasts, reflecting a worldview in which boundaries between species were permeable. These tales mirrored real observations. The molting of snakes, the metamorphosis of caterpillars into butterflies, and seasonal changes in plumage suggested that transformation was a natural possibility extended into the mythic realm. The recurring theme of metamorphosis demonstrated an awareness of continuity across forms of life, an intuition that would later underpin evolutionary thought. Early natural philosophers sought to impose order upon the diversity of animals through classification. Aristotle's Historia Animalium in the 4th century BCE categorized species based on reproductive modes, habitats, and observable features, while retaining symbolic associations, linking lions to courage, for example. He described anatomy through dissection and observation, laying the foundation for zoology. His distinction between vertebrates with red blood and invertebrates without anticipated later taxonomic divisions. Yet the persistence of mythical creatures in bestiaries of the Middle Ages shows that empirical categorization and symbolic imagination coexisted for centuries. Medieval European bestiaries merged Christian allegory with zoological description. The pelican, said to wound itself to feed its young with its blood, symbolized Christ's sacrifice. The phoenix, reborn from its ashes, embodied resurrection. These symbolic interpretations overshadowed empirical accuracy, yet they preserved detailed descriptions of animal morphology and behavior, ensuring transmission of zoological knowledge through religious frameworks. In this way, mythic transformation served didactic purposes while embedding observations of real animals. The Renaissance introduced a reorientation toward empirical study. Naturalists such as Conrad Gessner, in his Historiae Animalium, 1551 to 1558, compiled encyclopedic descriptions of animals, drawing on classical sources, travelers' reports, and personal observation. His work included both real and mythical creatures, but by presenting them side by side, it created space for skepticism. As voyages of exploration expanded knowledge of fauna, creatures once considered mythical, such as the gorilla or okapi, entered scientific description, while others, like the manticore or basilisk, receded into the realm of fable. The scientific revolution introduced systematic classification through Carl Linnaeus's Systema Naturae, 1735. By grouping species based on morphological characteristics and binomial nomenclature, Linnaeus stripped animals of their mythic associations, placing them within a universal taxonomy. Yet even here, traces of myth remained. His naming drew upon classical figures, embedding symbolic resonance within scientific categories. The impulse to order and the impulse to mythologize intertwined, producing a system both empirical and culturally saturated. Darwin's theory of evolution by natural selection, published in On the Origin of Species, 1859, redefined transformation not as sudden metamorphosis or divine punishment, but as gradual modification across generations. Variability within populations, differential survival, and inheritance produced shifts in form that explained the diversity of species without invoking mythical hybrids. The theory reframed myths of transformation into evolutionary processes, linking the metamorphosis of insects, the adaptations of finches, and the fossils of extinct species into a single explanatory framework. Even with evolutionary biology, animals retain symbolic power. Totemic traditions persist in indigenous societies, where animals represent ancestral lineages and ecological responsibilities. In modern culture, wolves, eagles, and serpents continue to function as symbols of power, freedom, or danger. The persistence of shapeshifter myths, werewolves, kitsune, narwhals, reveals an enduring fascination with the boundary between human and animal, reflecting both psychological projection and residual uncertainty about the limits of transformation. Contemporary science extends the theme by probing mechanisms of biological change. Developmental biology investigates how genetic regulation produces metamorphosis, from tadpole to frog or caterpillar to butterfly. Evodevo research demonstrates how small modifications in regulatory genes generate profound morphological differences, linking mythic fascination with transformation to molecular pathways. Genetic engineering and synthetic biology push the boundary further, creating organisms with traits assembled by human design, raising questions about whether the symbolic fears of hybrids and chimeras foreshadow contemporary debates over biotechnology. Animals, once mythologized as embodiments of divine power or liminal beings capable of shifting form, now serve as subjects of molecular sequencing, ecological modeling, and conservation biology. Yet the tension between observation and imagination persists. The discovery of deep-sea species with luminous organs or extremophiles surviving in boiling vents echoes mythic imagery, reminding observers that nature itself produces forms as strange as those once attributed to imagination. Each new discovery challenges the line between the familiar and the monstrous, sustaining the sense that transformation is both a biological reality and a symbolic necessity. The fascination with animals and their capacity for change continues to unsettle fixed categories of thought. As genetic modification, cloning, and artificial intelligence blur the distinctions between species and between organism and machine, the ancient impulse to narrate transformation re-emerges in scientific debates. The boundary between myth and biology, once sharply distinguished, grows porous again, pressing inquiry toward domains where human power over transformation is matched by anxiety about its consequences. Among the elements encountered by early humans, none carried greater transformative potential than fire. Its heat provided warmth in cold climates, its light extended activity into the night, and its power to cook altered the very physiology of digestion. Yet its origin and control remained enigmatic. Myths across cultures portrayed fire as a gift stolen from gods, seized through trickery or bestowed with conditions, a framing that reflected both its indispensability and its danger. Fire was not simply a tool but a threshold between survival and destruction, its dual nature requiring explanation in symbolic as well as practical terms. Greek tradition placed Prometheus at the center of fire's origin. By stealing it from the heavens and giving it to humanity, he conferred the possibility of civilization while incurring divine punishment. In Polynesian myth, the demigod Maui obtained fire from the underworld, sometimes by extinguishing it in his hands and reviving it through friction, echoing real techniques of ignition. Vedic hymns personified fire as Agni, the mediator between gods and humans, carrying offerings skyward in smoke. Across these traditions, fire was treated as a sacred substance, its acquisition a transgression or a privilege. The persistence of such stories reveals how profoundly fire altered the trajectory of human existence. Archaeological evidence confirms that controlled use of fire extends back at least 400,000 years, with hearths documented at sites such as Gesher Benot Yaakov in Israel. Evidence of charred bones and lithic artifacts suggests deliberate control rather than accidental burning. Fire-hardened wooden tools expanded diets through cooking of starches and proteins, and offered protection against predators. Richard Wrangham's cooking hypothesis argues that the nutritional advantages of cooked food contributed to the reduction of tooth and jaw size and the expansion of brain volume in early Homo species. Mythic explanations for fire's origin, then, preserved symbolic memory of a transition that reshaped human biology itself. The technological applications of fire expanded over millennia. Pottery, hardened by kiln firing as early as 29,000 years ago in Central Europe, allowed storage and transport of food. Metallurgy, emerging around 6000 BCE in the Near East, required mastery of higher temperatures. The smelting of copper ores, followed by alloying with tin to produce bronze around 3300 BCE, transformed tools and weapons. By the first millennium BCE, iron smelting had spread widely, demanding furnaces reaching over 1,200 degrees Celsius and sophisticated control of airflow. Myths often frame these processes in divine terms. Hephaestus in Greek lore or Vulcan in Roman religion served as smith gods, their forges hidden within mountains, mirroring the furnaces of human metallurgists. Scientific inquiry into fire's nature began only much later. For centuries, combustion was explained through the theory of phlogiston, a hypothetical substance released during burning. Proposed in the 17th century by Johann Joachim Becher and elaborated by George Ernst Stahl, the theory dominated European thought until Antoine Lavoisier's experiments in the 1770s. Using carefully measured weights, Lavoisier demonstrated that combustion involved the combination of substances with oxygen rather than the release of phlogiston. His meticulous work with balances showed that mass increased when metals were calcined, contradicting phlogiston theory. This marked the beginning of modern chemistry, transforming fire from divine essence into oxidation reaction. The study of heat followed. In the 19th century, James Prescott Joule's experiments established the mechanical equivalent of heat, demonstrating that energy could be converted between forms but not destroyed. The caloric theory of heat, which had treated it as a fluid, gave way to the kinetic theory, describing heat as the motion of particles. Fire, once sacred flame, became quantifiable energy exchange, its processes described through thermodynamics. The first and second laws, formalized by Rudolf Clausius and William Thomson, Lord Kelvin, defined conservation of energy and the tendency toward entropy, placing fire within universal physical principles. Applications multiplied as understanding deepened. Steam engines, pioneered by Thomas Newcomen and improved by James Watt in the 18th century, transformed heat into mechanical power, driving the Industrial Revolution. Combustion engines in the 19th century compressed fire into cylinders, propelling vehicles and reshaping landscapes. Electricity generation by burning coal, oil, or gas converted chemical energy into light and motion at industrial scale. Each advance extended humanity's reliance on fire from hearth to machine, embedding it in every aspect of modern society. Yet the destructive dimension remained. Urban conflagrations: Rome in 64 CE, London in 1666, Chicago in 1871, revealed fire's capacity to erase cities as rapidly as it had built them. Wildfires, whether ignited by lightning or human action, continue to devastate ecosystems, their spread amplified by drought and wind. Modern fire science investigates flame fronts, fuel loads, and atmospheric interactions, deploying satellites and computational models to anticipate behavior. Even so, prediction remains imperfect, and fire's destructive unpredictability echoes the mythic framing of it as a volatile, almost living force. At the frontier of physics, fire is reinterpreted as plasma, the fourth state of matter. Laboratory research investigates high-temperature plasmas not only as phenomena of combustion, but as pathways to fusion energy. Experiments at ITER in France and the National Ignition Facility in the United States attempt to replicate the nuclear reactions that power stars, harnessing plasma confinement to achieve sustained energy release. If successful, such efforts would extend the human relationship with fire from chemical oxidation to stellar processes, a transformation that recalls but also surpasses the mythic imagination of fire as divine. Cultural symbolism remains persistent. Fire rituals, candles in religious ceremonies, Olympic flames, eternal memorial fires, encode continuity of life and memory. The symbolic association of fire with knowledge, power, and danger persists in literature and political language. Even as chemistry and thermodynamics dismantle its mysteries, fire retains its capacity to embody ambivalence. Benefactor and destroyer, human tool and elemental threat. And while humans have learned to ignite, contain, and exploit fire in controlled contexts, questions remain over how to sustain its benefits without amplifying its hazards. Combustion-driven industry accelerates climate change through greenhouse gas emissions, binding fire's mastery to global instability. The same element that once provided survival advantage now forces inquiry into alternatives: renewable energy, nuclear fusion, and novel technologies that may redefine fire's role. Yet whether contained in hearth, furnace, or reactor, it remains central, demanding continual negotiation between knowledge and risk, between mastery and vulnerability. If fire marked the threshold of technological power, knowledge itself became the domain most jealously guarded by gods in myth. Across civilizations, stories describe wisdom, writing, or astronomy as sacred gifts or stolen treasures, their possession portrayed as both necessity and transgression. Such framing reveals the ambivalence with which societies regarded knowledge, indispensable for survival, yet dangerous when pursued without restraint. The myths surrounding divine teachers and tricksters capture this tension, encoding the costs of inquiry while foreshadowing the institutionalization of science. In Egypt, Thoth embodied knowledge and writing, credited with inventing hieroglyphs and regulating the measurement of time. Priests associated him with lunar cycles, calendrical precision, and astronomical observation. His role was not only mythic but administrative, since scribes operating under his patronage maintained records of taxation, harvests, and rituals. By attributing writing to divine origin, the Egyptians elevated its authority, embedding practical literacy in a sacred framework. The myth justified the consolidation of knowledge in priestly hands, restricting access while ensuring continuity across dynasties. In Mesopotamia, the god Enki Ea held the me, decrees of civilization encompassing laws, crafts, and sciences. Myths describe how Inanna, goddess of love and war, acquired them through cunning, bringing them to Uruk. The narrative conveys both the desirability of knowledge and its contested distribution. Wisdom was power, capable of being stolen, bargained, or hoarded. The cuneiform tablets unearthed from Sumerian and Babylonian archives show the practical outcome of such mythic framing. Records of astronomical observations, medical prescriptions, and mathematical calculations embedded in systems of authority. Norse tradition presents Odin as a seeker of wisdom through sacrifice. He hung upon Yggdrasil for 9 nights, wounded by his own spear, to gain the runes, symbols of knowledge and magical power. He sacrificed an eye at Mimir's well to drink from its waters of wisdom. The costliness of knowledge in these myths illustrates a principle echoed in later scientific history. Understanding requires risk, discipline, and often suffering. The cultural lesson was that wisdom could not be obtained without price, a notion that resonated with the arduous demands of empirical inquiry. In Mesoamerican civilizations, Quetzalcoatl, the feathered serpent, was associated with the gift of maize and the arts of civilization, including astronomy and the calendar. His mythic role reflected real achievements of priest astronomers, who developed complex calendrical systems such as the 260-day ritual calendar and the 365-day solar calendar, interlocked to produce a 52-year cycle. Observations of Venus, encoded in codices like the Dresden Codex, enabled predictions of its appearances and disappearances with remarkable accuracy. These achievements were inseparable from ritual and myth, demonstrating how divine figures framed technical expertise. Greek myths combined cautionary tales with symbolic elevation of knowledge. Prometheus's theft of fire represented not only physical flame but the broader acquisition of techne, skill, and craft. His punishment signified the danger of overreaching. The myth of Pandora further underscored ambivalence. Curiosity and the opening of a forbidden container released evils into the world. These narratives framed inquiry as simultaneously necessary and perilous, echoing in philosophical debates on the limits of human reason. Plato and Aristotle both inherited this duality, situating knowledge within metaphysical and ethical concerns while also laying foundations for systematic observation. The institutionalization of knowledge occurred most visibly in ancient libraries and academies. The Library of Alexandria, founded in the 3rd century BCE, sought to collect all texts, reflecting an ambition to centralize wisdom. Legends describe Ptolemaic rulers seizing books from ships entering the harbor, copying them, and preserving originals. Although the library's fate remains debated, its existence symbolizes the transition from mythic framing of knowledge as divine gift to civic ambition for universal collection. This transformation foreshadowed modern repositories of data, where accumulation itself became a form of power. Medieval traditions maintained the linkage between divine authority and learning. In Islamic contexts, the Quran framed knowledge, ilm, as sacred pursuit, inspiring translation movements in Baghdad's House of Wisdom during the Abbasid Caliphate. Greek texts on astronomy, medicine, and mathematics were translated into Arabic, preserved, and expanded by scholars such as Al-Khwarizmi and Ibn Sina. In Christian Europe, scholasticism attempted to reconcile Aristotelian philosophy with theology, embedding inquiry within ecclesiastical structures. Across both traditions, knowledge was still considered sacred, but its custodianship gradually shifted toward systematic commentary, debate, and classification. The Renaissance reintroduced the theme of forbidden knowledge, especially in alchemical and magical texts. Alchemists sought transmutation of metals and the philosopher's stone, often framing their work as retrieval of secrets hidden by God in nature. The secrecy of alchemical writing, filled with symbols and allegories, mirrored the mythic idea that knowledge must be concealed from the unworthy. Yet within these texts lay careful records of laboratory techniques, apparatus, and experimental results, providing a bridge to modern chemistry. The myth of hidden wisdom functioned as a protective cloak, allowing empirical practice to persist under suspicion. The Enlightenment reframed knowledge as public good rather than divine secret. Encyclopedias compiled by Denis Diderot and Jean-Le-Rond d'Alembert sought to democratize learning, while scientific societies formalized peer review and experimentation. Yet even here, echoes of myth persisted. Isaac Newton, though architect of mathematical physics, also devoted decades to alchemy and biblical prophecy. His search for universal laws resonated with the mythic idea of hidden structures binding the cosmos. The blending of rational mathematics with symbolic quests reveals continuity between divine myths of knowledge and scientific ambition. In modern science, knowledge is distributed through institutions, journals, and digital archives, but its pursuit still carries costs reminiscent of myth. Laboratory accidents, radiation exposure, and ethical dilemmas testify to the risks borne by those who probe boundaries. Nuclear physics, genetics, and artificial intelligence provoke debates framed in terms not unlike mythic warnings. Are humans seizing powers once reserved for gods? The language of Pandora's box and Promethean fire recurs, showing how ancient symbols remain embedded in assessments of scientific risk. The ambivalence persists because knowledge retains its double edge. It enables medicine, technology, and exploration, yet it also produces weaponry, surveillance, and ecological disruption. Myths of gods gifting or guarding knowledge foreshadowed this paradox, embedding caution within the very act of inquiry. The continuation of that tension ensures that each expansion of scientific capability raises questions about boundaries, responsibility, and whether some domains of knowledge remain too powerful or too dangerous to pursue. The trajectory of human inquiry reveals not a clean break between myth and science, but an ongoing negotiation in which symbolic imagination and empirical method intertwine. Myths encoded the first efforts to impose coherence upon a world filled with uncertainty, embedding observation within stories that made survival knowledge memorable and authoritative. Science emerged not by erasing these frameworks but by reframing them, translating symbolic order into experimental verification, narrative causality into quantifiable law. The continuity is visible in the language of modern science itself. Terms such as genetic code, the book of nature, and the tree of life reveal metaphors inherited from older cosmologies. The persistence of such imagery suggests that human cognition still relies on mythic scaffolding to articulate discoveries that resist direct representation. Even the Big Bang, a phrase coined by Fred Hoyle in 1949 as a dismissive remark during a BBC broadcast, carries mythic resonance of sudden creation, echoing earlier cosmogonies of order arising from chaos. At the same time, the institutions of science diverge from myth in their methods of validation. Where myths derived authority from ritual repetition and communal acceptance, science depends on reproducibility, peer review, and falsification. This transition was neither immediate nor universal. Alchemy, astrology, and natural philosophy persisted for centuries alongside experimental science, blurring boundaries between symbolic and empirical knowledge. The same laboratories where early chemists weighed reactions also housed texts of mystical correspondences, revealing the overlap rather than the replacement of explanatory systems. The endurance of mythic framing in modern contexts is not limited to metaphor. Scientific projects often adopt symbolic narratives to mobilize support or to convey significance. The Apollo program invoked imagery of heroic quest, casting astronauts as explorers entering realms once reserved for gods. The Human Genome Project was described as decoding the Book of Life, framing a complex technical undertaking as a Promethean effort to unveil hidden truth. These examples demonstrate that even in advanced science, mythic patterns continue to provide meaning beyond data. Yet science also destabilizes older narratives by extending knowledge into domains myth never conceived. The telescope revealed galaxies beyond comprehension. The microscope exposed organisms invisible to the naked eye. Particle accelerators probe matter at scales where familiar categories dissolve. Each extension challenges the adequacy of mythic frameworks, producing new forms of wonder and uncertainty. Quantum mechanics, with its probabilistic nature, and cosmology, with its hypotheses of multiverses, echo mythic concerns with origins and limits, yet they do so through mathematics and instrumentation rather than sacred story. The persistence of myth-like questions within science underscores a fundamental continuity. Humans seek explanations not only for how phenomena occur, but why they exist at all. Cosmology asks why there is something rather than nothing. Biology investigates the origins of life from inert chemistry. Neuroscience interrogates the basis of consciousness. These are not merely technical inquiries but existential ones, demanding interpretive frameworks that resonate with meaning. Myth provided such frameworks in earlier eras, and science continues to confront the same horizon of mystery, though through different means. The ethical dimension further connects the two domains. Myths often warned of hubris. Mortals who challenged gods suffered punishment. Scientific inquiry carries analogous risks when power outpaces wisdom. Nuclear weapons, genetic modification, and artificial intelligence provoke debates framed in cautionary terms. The recurring invocation of Prometheus or Pandora in contemporary discourse signals the endurance of myth as a cultural vocabulary for grappling with the dangers of knowledge. These references highlight that science, like myth, must negotiate the boundary between curiosity and restraint. Modern epistemology recognizes that scientific models are provisional, subject to revision as new evidence emerges. This openness contrasts with the fixed authority of myth, but also reveals vulnerability. Knowledge is always incomplete. Karl Popper emphasized falsifiability as the demarcation of science, yet even theories that withstand testing remain approximations. This recognition mirrors the Rigvedic hymn that questioned whether even the gods know the origins of existence. Both myth and science acknowledge limits, though they express them differently. One through humility before divine mystery, the other through acknowledgement of methodological boundaries. The ongoing interaction between myth and science is evident in public perception of scientific ideas. Concepts such as the Higgs boson as the God particle, or CRISPR technology as gene editing scissors, frame complex discoveries in myth-inflected metaphors that make them culturally intelligible. These framings carry risks. They oversimplify or distort, but they also ensure engagement. The line between scientific literacy and mythic storytelling remains permeable, ensuring that knowledge circulates within symbolic as well as technical registers. The future of inquiry continues to raise questions with mythic resonance. Efforts to create artificial life, to explore exoplanets, or to extend human cognition through neural interfaces confront limits reminiscent of ancient narratives about forbidden knowledge and transformation. Each frontier generates unease that echoes older cautionary tales, suggesting that myth is not merely historical residue, but an enduring mode of thought accompanying science into new domains. Science may displace older explanations of storms, disease, or fire, yet it encounters new mysteries at cosmological, quantum, and cognitive scales. These mysteries demand narratives that connect technical detail to human meaning, a demand that myth once fulfilled and that science now inherits without fully satisfying. The dialogue between symbolic imagination and empirical method remains unresolved, pressing forward as questions outpace answers. And as inquiry advances into territories where experiment and measurement strain against the limits of comprehension, the human mind continues to weave symbolic frameworks around discovery, ensuring that the story of knowledge is never complete but always unfolding into further uncertainty.